So our last graphing quadratics lesson is about graphing quadratics when they are in intercept form. So we've looked at vertex form, standard form, and intercept form. So you're going to take some notes on intercept form and then do some mixed practice. So our equation that we're going to be looking at today is this one. So it's still a quadratic because x times x is x squared. A has the same job in intercept form as it does in vertex and standard form. You've got a factor, x minus p, and another factor, x minus q. So we're going to talk more about factoring next unit, but just know that when you have a factor like this, it's going to help find x-intercepts. So this is called intercept form because you can immediately identify the x-intercepts of the quadratic. Just like in vertex form, you can identify the vertex of the quadratic. So A again is your concavity and your steepness. So just like the other two forms, if A is positive, you're concave up. A is negative, you're concave down. If A is a number like 2, 3, or 4, you're going to be steeper. And if A is a fraction, you're going to be less steep. So you're going to be like a wider U shape. All right, so P and Q are the x-intercepts. P comma 0 and Q comma 0 are the x-intercepts of your parabola. All right, so the vertex is halfway between the intercepts. I should say the x value of the vertex. So we're going to use the intercepts to basically find the line of symmetry for this parabola. All right, so here's my first example. The x-intercepts are what x value that you have to plug in that would make this factor equal 0. So if I plug in negative 2 plus 2 would make this 0, and we know that 0 times anything else is 0. So if I plug in negative 2, I would get 0 times negative 4, right? And 0 times negative 4 is 0. So one of our x-intercepts is at negative 2. And the other x-intercept is at positive 2 because 2 minus 2 is 0. And this would be 0 times 2 plus 2. 0 times 4 is 0. So my two x-intercepts are at negative 2, 0 and positive 2, 0, which puts my axis of symmetry right down the middle, right at x equals 0. So if my vertex is somewhere along that axis of symmetry, what I need to do is take 0 and plug it into the original equation for x. So I would get 2 times negative 2, which is negative 4. So my vertex must be at 0, negative 4. And the A value information just tells me that I'm concave up, and I'm the same as the parent function. So let's review that parent function one more time. Can you say the key points with me? 0, 0, 1, 1, 2, 4, and 3, 9. So from the vertex, over 1, up 1, over 2, up 4, over 3, up 9. Number 2, intercept form. My A value this time is negative 1/2. So I'm going to be concave down, and I'm going to be shrunk times 1/2. So if my original parent function is 0, 0, 1, 1, 2, 4, 3, 9, let's review what it is to be shrunk times 1/2. 0, 0, 1, 1, 2, 4, and 3, 9. What does that become? Multiply all your y values times half of the steepness. 0, 0, 1, 1/2, 2, 2, and 3 comma 4.5. So all the same x values, but different y values. So now we have to figure out where my intercepts and vertex are. So x plus 6 tells me that if I plug in -6, I would get 0, so I'd have one of my x-intercepts. If I plug in -2, I get my other x-intercept. So your x-intercept is always going to be opposite of the factor, because when you plug in -6, if you add 6, you get 0. So here's -6, here's -2. That puts my axis of symmetry right in between at x equals -4. So that tells me the x value of my vertex is -4. I'm going to plug that back in and see what I get. -1/2. Let's see, -4 plus 6 is +2. -4 plus 2 is -2. -1/2 times -4 will be +2. So my vertex must be at -4, comma, +2. Does this make sense? Yes, because I'm concave down, shrunk by a half. Over 1, down 1/2. Over 2, down 2. Over 3, down 4.5. So there you go. All right, 2 more functions that we're going to do together. So graphing the quadratic given an intercept form. Here's my a value. So I'm going to be concave up, and I'm going to be taller. So stretch times 2. My intercepts are only one intercept this time, right? At 1 and at 1. So I'm just going to write that I have one x-intercept. I'm at 1, comma 0. So if I only have one x-intercept, that has to be my vertex, right? If you think about this function, couldn't I write this function 2 times x minus 1 squared? Right 1 is my vertex. My axis of symmetry is at 1. My vertex is at 1. I'm concave up with a stretched factor of 2. So I go over 1 and up 2. And then over 2, I normally go up 4. So this time I need to go up twice as much. So I'm going to go up 8. Right? So up 8. And that's as much as is going to fit. Example 4. My a value is -1, so I'm concave down. My intercepts are at -1, 0 and -5, 0. So I'm going to plot those on the graph, -1, 0, -5, 0. So that puts my axis of symmetry at -3. So here's -3. So my vertex is at -3, comma something. So I'm going to plug -3 into this original function, -2 times 2. Looks like +4 to me. So I'm going to graph -3, comma +4. Concave down, I forgot to say that it's the parent function, right? So over 1 up 1, over 2 up 4, over 3 up 9, except I'm going down. Over 1, down 1, over 2, down 4, over 3, down 9. Down 9. There we go. All right. So now you have 4 functions to do some guided practice on, right? Just one page. So you've got some that are in vertex form, some that are in intercept form, some that are in standard form. So take a look at those 4 different problems and send me a picture of this last guided practice page.